Welcome to Beyond the Brackets. In this session, we explore an important concept in infinite series, the root test or Cauchy's nth root test. A positive term series such that limit as n tends to infinity, un power 1 by n is equal to L, converges if L less than 1, diverges if L greater than 1, and test fails for L is equal to 1. We use the root test when the terms involve powers like something to the power n, especially for exponential type expressions, and when ratio test is difficult to apply. These are some standard limit results which helps in simplification when the test is applied. To begin with the first question, we are supposed to test the convergence of the series whose nth term is given. Observe that the entire term is raised to the power minus n square. This suggests that root test will be appropriate method to apply. Taking the nth root on both sides, we get un power 1 by n is equal to 1 plus 1 by n power minus n. That is 1 by 1 plus 1 by n power n. Applying limit as n tends to infinity, it simplifies to 1 by e, that is less than 1. So by root test, the given series is convergent. Moving on to the next question, the question says, show that the given series is convergent. If you observe the pattern of this question, the left side of the first term has 2 square by 1 square. The second term has 3 cube by 2 cube. The third term has 4 power 4 by 3 power 4. So the nth term will have n plus 1 power n plus 1 by n power n plus 1. The right side of the first term has 2 by 1. Second term has 3 by 2. Third term has 4 by 3. So the nth term will have n plus 1 by n. The first term has power minus 1, second term has power minus 2, third term has power minus 3. So the nth term will have power minus n. Again, the entire term can be written as power minus n. So root test is applicable for this question. Taking nth root on both sides, n plus 1 by n power n plus 1 can be written as n plus 1 by n power n into n plus 1 by n. The second term will be written as it is. N and 1 by n in the power gets cancelled and we are left with minus 1. In both the terms, n plus 1 by n power minus 1 will be common. So we are left with n plus 1 by n power n minus 1. Taking n common for the first term and the second term, n in the numerator and in the denominator cancel out and we are left with 1 plus 1 by n power minus 1 into 1 plus 1 by n power n minus 1 whole power minus 1. Taking both the terms to the denominator, the powers become positive. We know that limit as n tends to infinity, 1 plus 1 by n is 1. So the first term becomes 1. For the second term, limit as n tends to infinity, 1 plus 1 by n power n is e. So the second term becomes 1 divided by e minus 1. On simplification, this is less than 1. So by root test, the series is convergent. Let's look into the last question. We are supposed to find the convergence of the series whose nth term is given. Here the numerator is raised to the power n square and the denominator is raised to the power n. Taking nth root on both sides, 1 n will get cancelled and the numerator is n plus 1 by n power n and the denominator is 3. Taking n common in the numerator, terms gets cancelled and we are left with 1 plus 1 by n power n divided by 3. Applying limit as n tends to infinity, we know that limit as n tends to infinity, 1 plus 1 by n power n is e. So we obtain e by 3, that will be less than 1. Again by root test, the given series is convergent. That concludes our today's topic. Here some practice questions are included along with their answers.